Welcome to East Tennessee Pinball. Today, I'm going to try to make the coolest WrestleMania pinball machine there ever was. So I've got some East Tennessee Pinball merch for sale, some t-shirts made up. I'll put the link down in the bottom. But if you happen to be in Knoxville and you go to the tournaments or anything, if you know me personally, just tell me and I'll bring one to the tournament and save you the shipping and me the hassle of shipping it. Otherwise, just go to the link at the bottom and click through and I'll ship you one out. This is the front and the back. Some of y'all have experienced this act of God, not religious. This is the legal definition: a severe, unanticipated natural event for which no human is responsible. You got tornadoes, you got thunderstorms, lightnings, you got earthquakes, or 3 balls draining at once. I mean, freaking that! Is that an act of God? I think so. So Django heard me talk about cool pinball machine. He's all in. He's like, "What exactly are you going to do here?" Well, several things. And by the way, nothing I'm doing is going to be irreversible. Everything's going to be reversible. So if anybody doesn't like it, somebody later on, they can go right back. The first thing I'm going to do a little bit of rat rodding. If you're familiar with rat rodding, it's old cars and basically almost purposefully making them look old and junky, or use some old parts on a new car, or have an old car and not painting it or something. So kind of, I got these old legs back there. I kind of think they would go on here. I think that kind of works. I think I'm going to do that, and I might make myself some custom mounts here. I don't know if I'll do that. If I do, you'll get to see them later in this video. I don't want to prelude it yet because I may not do it, but I think I am. But some of the other things, so let me tell you a story. So me and buddy Jesse, buddy Thomas, we were in, let me sit down and tell you the story. So me and Jesse and Thomas, we were in Nashville playing at No Quarters, and we were in a tournament. We'd had a few beers, just a couple. And anyway, so we're playing the WrestleMania, and everybody's like shaking the hell out of this game, and I'm like, I can't believe this thing is tilted. And comes to find out, the tilt's taken off this game, and it's kind of like it's kind of the thing to do with WrestleMania is you take the tilt off and just let people throw it around. And I have to say, it was like one of the most cathartic pinball experiences I've ever had. I mean, I was down for the count. I was in third ball. I was behind, and I just like threw that thing all over the floor. And it's fine, it's part of it was kind of part of the sport, and came back and won the game. It was like so much fun. So I'm kind of wanting to do that, but I don't want it. I'm going to do it slightly differently. So I do want to keep the tilt, but it's not going to be hooked up to the machine as normal. So you're not going to get warning. I don't want to do it where you get warnings and then you tilt out. Don't want to do that. So here's my thing. So I was never really a big fan of WWF as a kid, and not now either, really. But I had lots of friends that were. So I'm kind of familiar with the stereotype, you want to say. And I've watched plenty of it, being around my buddies and when I was a kid. So, the wrestlers, and it's all real, of course, and if you take a big hit or you get thrown down, a double suplex, blah, 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 and you're stumbling around, blah, blah, blah. So my thought was to do this, design a little board interface kind of thing for this game such that if the plumb bob hits the ring, if you're kind of essentially tilted, it's not plugged into the machine, it's going to a different board that I'm going to make. It basically makes the flippers weak, very weak, and they basically don't have much power, and every time you flip, it takes a little bit longer for them to rejuvenate, to have enough power to soak up enough, basically have enough like battery energy, if you think of it like that way, before they can fire again. So if you flip once, you need to wait 2 or 3 seconds before you can flip it again, or if you hit it again, it's just gonna go blah blah blah. If you wait 5 or 6 seconds, you might get a good flip. So it's kind of like if you're more familiar with boxing or MMA, you take a good punch to the jaw. All you're trying to do is like not get knocked out for the next 10 or 15 seconds until you kind of get your bearings back. So that's kind of the thought process behind this is I want the flippers to behave like that. So if you tilt, if the tilt bob hits, instead of tilting out and losing your ball and game over, no, it's just a shot to the head, and you're kind of like sloppy drunk, and you don't really know what's going on. You can't flip very hard, and you can't flip very often. for about 10 seconds or so, and then you get your bearings back, and then you're ready to fight again. So that's the plan. So I scribbled out through half a dozen drawings, and I'm by no means an electrical engineer. I am an engineer, but everything I know about electricity is self-taught. So but I've got the first part of the circuit drawn up, and I've got it on my breadboard, and that part's working. I didn't completely write all this. I kind of copied a lot of it from schematics from System 11 board because I kind of knew what I kind of wanted to do. So I took the components off there, so I didn't have to size them all at that much. So I'll walk you through what I'm kind of doing here. Okay, so here's the schematics I've been working on. So I'll just kind of walk you through it. And I copied some of this. I mean, like this whole section here is the System 11, but basically from here to here. So I came up with this part, and I guess I did most of that, but a lot of it, the main meat of it, I just copied. This is just an RC circuit, and this is this is another RC circuit. When I say RC circuit, a resistor capacitor circuit, and this is just a relay. So I'm going to talk about this in terms of like, instead of electricity, a gas pressure analogy, so like air pressure. So I like to think of voltage as like air pressure. So 5 volts DC, if you think of 5 psi, that's an easier way to maybe think about it. If you're trying to kind of learn electricity and learn how these components work. So resistors, they resist the flow of the air through it. So you can think of a valve, and it's 220 kiloohms. That's a really big resistor, which means if it was a valve, it would just be barely letting the air barely flow through there. Then you got a capacitor at 47 microfarad. That's not very big. The capacitor is like an air storage tank, if you want to think of it. It's a fairly small air storage tank, but we just got a very, very small flow of air. So when this game turns on, just trickling air in there, and it takes some time for this air tank, if you like, or the capacitor, to charge up with air or voltage. And I used a RC calculator so that this should be about 8 or 10 seconds to charge up. Once it charges up, it goes to this transistor, and it's going to close this transistor. But before we get to that, we've also got the tilt bob wired into the circuit here. So if the tilt bob, so that would be the bob, and this would be the ring. If it closes, and that's closed, goes to ground, it basically lets all the air pressure out of it, or lets all the electricity out. It's back down to 0 volts again. So then it's going to take another 8 or 10 seconds for this to charge back up. So that's kind of the duration of this whole thing. Is if you tilt the game, you've got 8 or 10 seconds of this altered state. So what is the altered state? So I've got 2 transistors in series. This is real common. You see it on driver boards all the time. You got a little pre-transistor and the final transistor, and I didn't write my part number on there. I think it's a 2N4401. I'm going to write it right now. So that's a little pre-transistor, and these components are like directly out of a System 11 game. So you got a 68 ohm half watt resistor. This is 5 volts coming into the collector. Got the base signal up to 5 volts when it's in a non-tilted state, and the emitter, so you would have the 5 volts coming out, assuming you've got the 5 volts 5 volt coming at the base. So when that 5 volts comes at the base, it closes the switch, so it basically allows electricity to go through. You've got this little resistor here, which is 2.7 kiloohms. That's a huge resistor. So all that does is, if this thing, basically if you tilt, you lose your 5 volts coming in there. So it opens the switch. So you're not feeding it the 5 volts through here. It immediately bleeds off the little 5 volts in there because there's no capacitance. So basically, there's no place for the electrons to be stored. So just draining a few of them, it's back down to 0 real quick. All right, so then you got this diode 1N4004. That's really just to protect everything to the left of here, because to the right of here, you've got some 50 volt signal. So if you short this tip 102, and that happens, I've seen it. If y'all worked on pinball as much, you've seen it. You don't want that 50 volts going up here, getting your 5 volts and frying your whole motherboard and everything else has got 5 volts. So that's really just kind of a safety device. So if you've got the 5 volts there, then it closes this tip 102. This tip 102 is, you get the 50 volts coming in here. And what I've got is a flipper relay. So I'm going to take a flipper relay from a solenoid driver board off of Classic Valley. And basically, if it's got that signal there, it's going to allow the electricity to go through there, and it's going to allow this flipper relay to be energized. So to be in the energized state. So, or I may have this backwards. I think this one is a PNP instead of NPN. I have to look that up. I won't write on here because I read. I know my penmanship is sorry on this, but this is good penmanship for me because I believe this is in the normal state. This is down because I've actually already done a version. I'll show you here in a second. Put it on the breadboard. So in any case, in the normal state, the idea is that this relay. So it's got basically a make or break, a little reed switch. It goes back and forth, and so you've got the 50 volts that is powering this flipper relay when it's energized, and if not, it's just laying down on one of the posts, and that just provides the 50 volts to the flippers in the normal sense. When it's energized, well, so when you tilt, this thing's going to be energized because it's going to the other side. So for the flippers to get power, it's going to have to go through all this nonsense. So what is this nonsense? Well, first, and I don't know the exact values on there. I've kind of done a first stab at it. I think about 100 ohm resistor with a 6800 microfarad capacitor. That gives me a time constant of about 0.68 seconds. So what that means is with this resistor in there, this will, is that right? I deleted it. Anyway, it was about 2/3 of a second for this for one time constant. And the time constant will give this about 2/3 of a charge also. And after 2 time constants, it's about 85% of a charge because they charge exponentially up, well, asymptotically, I guess would be the term. So basically they kind of charge like that, where this is time and this is the charge. They initially charge pretty quick, and then they just asymptotically approach full charge. So in any case, so you're charging up this capacitor. It's a pretty big capacitor. Not huge, but, well, it's pretty good size. And this one I don't know if I'm going to put in there, a 1 ohm. So basically, and this goes to the flippers in the weak state. So the idea is you just trickling this, and this would take on the order of a second or two to get charged. And when it's charged, you only have 6800 microfarads of charge, which is not enough for a full flipper stroke. It'll be a little bit weak, and then potentially adding another ohm of resistance, because I haven't measured on this game or looked it up, but usually the power side of a flipper only has about 2 ohms or maybe even less of resistance. So adding another ohm is significant to the power side of it. Likewise, on a lot of flippers, the holding circuit would be about 20 ohms of resistance. So add another 100 here. So if you just held the button in, you're going to have 120 ohms total, or 121, as it should have this 100, another one, and then the flipper holding coil would be another 20. So 121 ohms. You're not going to have enough current to even hold the flipper up, I don't think. And that's kind of what the ideal is. So you start flipping, flip. It's just going to go went. It's going to wait 2 or 3 seconds. You get a flip. So you're in real danger mode, and that's kind of the goal. Is you just took the double suplex supremo from the top rope. You're just trying to stay alive till you get your bearings back. And if you don't, well, that's what you get for tilting. And if you do, oh, cool, even better. So I just think it'd be kind of fun. And these numbers here all these numbers are just kind of tentative at this point. And I might put in some pots, potentiometers, so they're basically just variable resistors. This one will be harder, or actually, well, yeah, that's not going to have too much power going. Well, it's going to have a little bit of power. When I say power, it's like how many watts are going through it. So, or because that becomes an issue with potentiometers. They have to get kind of big. And even this one, I'm gonna have to. That's gonna have to be a power resistor because it would burn up. I mean, that's gonna be. I should probably figure out how many watts it is. Why don't I do that real quick? So I wrote down about the only two equations I know about electricity: Ohm's law, and I don't even know the name of this one. Power is voltage times current. So that's voltage is equal current times resistance. So I know so I just solve this for current. So current equals voltage divided by the resistance. Take that I, substitute it into here, and I get power equals voltage squared divided by resistance. So my voltage is 50, so 50 squared. My ohms is 100, so that gives me 25 watts. So that's 25 watts is a pretty big honking resistor. I could probably get by with something less than that because this is going to be intermittent. The idea is for this to run for like 8 or 10 seconds, and only when you're flipping. If you're not flipping, it's not no current going through there. And in the normal play, this has a chance to cool down again. So it's kind of a duty cycle issue. So you might be able to get away with a 10 ohm or a 10 watt here. If and if it burns up a resistor, it's not the end of the world. I don't have any 25 watt, 30 watt resistors. I've got a bunch of 10 watts, so I might put two of them in series, and I don't have any 100 watt ohm anyway, so I'm probably gonna have to put several in series, and that way I probably could spread the heat out enough to do it. But anyway, so let's get back to what I've got built so far. So I bought this little breadboard on Amazon. I had one like a decade or two ago, and I hadn't used it, and I got rid of it or lost it or whatever. But this whole thing and all these little connectors, it was like $8 or $9, and it came with little power supplies, a little 5-volt power supply, kind of cool. So here's my 47 microfarad capacitor. There's my little pre-transistor right there. There's my tip 102. So basically, I've got everything on my drawing here. I've got everything up to just to the tip 102. I don't have anything beyond that. I don't have my flipper relay or any of that. So, but everything seems to be working. So if I hook my multimeter up to the 5-volt on one side, and I actually, as drawn here, I put a little on the output of this tip 102 because I don't have this flipper relay, and I'm actually just passing 5 volts because that's all I've got here on the bench is 5 volts. I'm passing the 5 volts through this tip 102. I just put a resistor on here so it's not shorted from the 5 volts to the ground here. So if I measure on the upside of that resistor on the output of that tip 102, so I'm basically measuring right here, we can see what happens when I close a tilt bob. And in this case, my tilt bob is this little wire here, this little dead end one. If I stick it to ground, we'll see the activity. So let me go get my multimeter and put this camera on the stand, and we'll see how it works. Okay, so I got it hooked up. I've got the red hooked to the 5 volts coming in, and I've got the black hooked up to the output of the transistor there. So if I power this thing up, it initially went to the 5 volts, but it's draining back down. So when it first came up, it had the 5 volts going through this transistor, but this one had to charge up. So it's draining back down, down. So it's in basically, this relay is in the off state, or it's getting to the off state. Again, I may need to tweak some of these resistors and capacitors. As soon as I put this pin into the ground, it's back to the 5 volts. Now it's charged up, so now you're in the holy crap, my flippers don't work very good. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, you know, about 3, 4 volts or something. That is going to be open, and or it's not going to be enough voltage for that flipper relay coil to be working. So I think this is basically working how I want it to. So I've just got to, well, I'm gonna have to get a 50 volt or a bigger power supply run through that tip 102, and go desolder a flipper relay off of a solenoid driver board. I've got a bunch of them, and so I guess that's what I'll do next. So this board's a good candidate. It's got not much left beyond the relay, so that's what this board is used for. When the game boots up, you hear it click, and it this is what energizes the flipper. You see in there, there's a little make or break switch in there, and that's what we're going to use. This one's controlled by Q15, I believe. But in any case, I'm going to desolder this sucker, yank it off of here, and I guess I'll pick up some jumper wires or something and see if we can get it and find a voltage supply that's kind of around 50 volts and see if we can get it to work. That wasn't too bad. Maybe clean these legs up just a little bit. So I believe, I'm looking, I think these two are wound to the coil that makes this. You know, let me zoom in here a little bit. There we go. So I believe those two legs go to the coil, and when it pulls in, that there slides to the other side and connects those, I think those two pins together instead of those two pins together. Or maybe it's this one, or this one and this one, depending on the state. I think that's what it is. This one is normally connected to that one, and when it's closed, this one connects to that one. We can check all that with the multimeter. I'm going to do that real quick here. We'll see what's connected to what. And if we've got like 10 or 20 ohms of resistance here across this. So we got 2.9 kilo. Oh, that's actually going to be a lot of resistance because this thing's on all the time. So it's, I guess we could look at the schematics and really figure it out. These are all open. .9 kilo ohms. That seems like too much. I can see that lead is right there. I wonder if this is a... Surely it's not 2.9 kilo ohms. Maybe it's bad. I'm going to go get another one and check it real quick. Are you filming?
Yeah, I'm filming.
Okay. All right, so I measured another one of these coils in the board, and it was also 2,700 ohms on the coil. I wasn't expecting to be that much. So I'm just going to test this one out that I've got out. I've got this WrestleMania up here. I measured that. That's 47 volts going to the coil. I've got the other leg down to the ground braid, and when I touch it on here, you can probably hear it clicking. You can see it. That switch going from one side to the other there. And so that's what I'm going to use. That's going to be the normal side, and when it's powered, it's going to be on the weakened flipper mode. So the next part of this I'm going to have to do is basically take that prototype board and wire this in line with 50 volts through the tip 102 such that I can get the board to operate this using 50 volts either from this machine or another source. I'd really not rather use the machine when I'm playing around, because if I screw something up, I don't want to fry the board on this. But this is convenient and easy, so you know, live by the sword, die by the sword, I guess. So that's the next step. Okay, I got some jumpers on here tied up to the collector emitter of my tip 102, and I've got those run over here to my relay. Got the one end of my relay ran over to ground. I've got the emitter run over here to the other side of the relay, and I just got to hook up the hot side and then also turn on here. That just puts 5 volts to this. First I got to turn on 50 volts for the machine. Now I got 50 volts. Before I do anything, I'm just gonna do an arc test, see if it like. Okay, you can't see what I'm doing here. So it didn't shock or do anything. So let's see what happens when we turn it on. Nothing. We ground it. I can get the pin to go in. Still nothing. It never actuated. I would think I would have heard it. Nope. No joy. I think that's just an extra one I've got hooked up there just so I can measure the 5 volts off of it. I think I've got everything hooked up. Something's not right. Or I got a bad design, I'm not sure. Well, I think I'll pull this back to the bench and start measuring and see what's going wrong. It's not working at all. Okay, so I'm back from delivering that game. This blue wire here, that was the diode. I swapped it out. It seems like things are working better now. Everything's making sense. So I'm measuring 5 volts on the board on one side going in, and I'm measuring the voltage on the output here. This is the output from my primary transistor here. Right now I don't have it grounded, so it's trickled down to 1.5 volts. If I ground this thing, pops up to 5 volts. If I unground it, it kind of slowly drifts back down to something that's not going to be, well, enough to run the coil on the flipper relay. So I think what I'll go ahead and do, I think I've got it working now again. I think with that diode removed, I think I'll try to store it back in the game and see if I've got it working. I think I've actually got things in the backwards sense though, from what I thought, because when I'm measuring the 5 volts, that basically means that this is ground when I'm measuring 5 volts. So it means I'm turning the power off to the coil, which means so it doesn't really matter which way the coil goes. I guess it burned a little bit of coil, but that coil doesn't take very much power to run, because I mean it's in its current use, in its previous usage, its life as a solenoid driver board in a Bally game, that thing is on all the time, so it's fine being on. So it doesn't really matter. I think if I swapped this 2N4401, and again, I said earlier, for y'all it was like 5 minutes ago. For me it was several days ago. Whether this was an NPN or PNP, I think that determines whether the polarity, whether it's normally on or normally off. That's not exactly the way it works, but something along those lines. Again, I'm kind of a novice at this. I believe if I do that, if I got the daughter or the sister of this 2N4404, I could change the polarity of this thing turning on versus turning off when I ground this. So anyway, the first thing I'm going to do is throw it in the game and see what happens, see if I can smoke something. Okay, so I got this back in the game again. Again, that's our tip 102. This red wire here, I'm just stealing 50 volts from a coil lug. That's going into the transistor. What's coming out is the yellow one. It's going to the flipper relay coil, and then the ground side of that's going back to the ground of the machine. So I'm going to turn on the game here first. If I can find the switch. There, the game's on. Yep. Don't have the 50 volts because I don't have the plug. So this is kind of the scary part right here. See if anything smokes. Okay, we got the 50 volts on. I didn't hear this thing click. Let me power this thing up now. Power the 5 volts for the circuit. I still don't think I heard it click. Let me ground this. And I still don't think I heard it click. Let me see if I can. Well, I am still not getting 50 volts through that transistor. Huh. Well, I think I'll get the multimeter and start figuring out what's going on. I'm almost positive I've got the 50 volts right there. Measured that a second ago, so it's just not coming through. I don't know what. Let me unplug this and give it a few seconds. Maybe I'll put y'all in the stand. Y'all can watch me measure this stuff, and maybe y'all can figure out what's going on and I can't. So yesterday evening, I messed around with this board. Never could get it to work. I went home last night, did some studying, and I think I figured out what it is. Although I think I've got this drawn correctly. I've got my flipper relay first, and then the transistor second, so that the downside of this transistor goes to ground. When I put it in the machine, I had it the other way. I basically had the transistor first, so the power coming into the transistor and then it coming out and then going through the coil, and that doesn't work. So that for sure is a problem. There may be other problems, but that is a big problem because I don't have the little. I should have drawn the little arrows on here. So this would have a little arrow, which essentially represents there's this diode in there. So this is a 5 volt signal coming in here. So it needs to have the 5 volt. Not only does it have to have the voltage, it has to have a current going through here. So for that to have a current going through here, you can't have 50 volts or on the other side. And basically, if this is going through the coil afterwards instead of before, you're going to have 50 volts all the way up to the coil, and then the voltage drop is going to happen through the coil. So I wired it up backwards in the game. So maybe that's all the problem is. Maybe I can put this diode back, and maybe I can swap all my resistor values back. I did a lot of stuff off camera also. I was just trying to figure out what was going on, and I didn't realize this until I got home and was looking at it again. So I'm going to try it again, put it in the machine again with, as drawn here, with the coil on the front side and the transistor on the downside of the voltage. So after it goes through the coil, you've already got you're basically almost down to earth because you got your voltage drops right there. So the 5 volts can easily get through here. You can't have you can't have high voltage on the downside of that diode, or you can't go from 5 uphill to 50 through that diode. It's not going to work. You won't get the current, and then that transistor won't open up. So I think that's the problem. So I'm going to try it out and see what happens. Okay, so I finally got this thing working. It was indeed the fact that I had the transistor before the relay instead of the relay before the transistor in terms of the 50 volts. So that was a problem. Another problem was I did need to have the 5 volts and the 50 volts have the common ground, because that was also a problem. So I've got this thing hooked up in a Bally Black Pyramid. So I'm using the voltages on there. So I got a 43 volt for the solenoid, and I'm taking the 5 volts off here. Unfortunately, it's a new driver board, so I don't have all the little wire test points. So I did have one on this auxiliary driver board for the 5 volts. But the 43 volts, I've just got this test point here. It's just a pad, so I'm just going to hold the jumper up there and Jesse's gonna hold the camera for me, and we'll see how well this thing works. You recording?
Mm-hmm.
All right, so I'm gonna press or connect this, and you'll hear the relay click on and off. And actually, you can see it as I go back and forth there. So it's energized right now, and now this green wire here, if I ground that, that'd be my tilt bob being grounded. So I'm going to hit it right now. It clicked, so it's energized. And now if I take it off, it'll be about 10 seconds. There went about 11 seconds right there. So I've got this part of the circuit working. So now I've just got to wire up the two sides of this, the normal, which is going to power the flippers normally, and the other side is going to be the WAF. That'd be weak ass flippers. It's been a couple days since I filmed the last segment, and I'm wanting to take all these parts and mount them to this little board here, so I have kind of like a permanent solution. When I do this, I'm going to probably socket that resistor and that capacitor, because that's the RC part of this that is going to be well, that controls the timing of the circuit. So, and I'm not convinced that that's where I might want to change that in the future. So if I just put some sockets, and I can just swap those resistors or capacitor out pretty easily. I really shouldn't be doing this. I really should be working on this funhouse. I just need to swap the top over, but it's Friday and I'm just not feeling it. So this just is a lot more fun to me for the moment. So this is what I'm gonna do for today, at least for, well, not the whole day, but for a couple hours. So this piece here that's got these big fat legs, they won't fit, so I'm going to drill this out. I've got it marked already here, and so I won't be able to exactly solder in place. I may drill it out and just tack it in place, hot glue it in or something, and then, but I'll have all the leads on the other side that I can attach to, but I'll have it mounted to the board in any case. So you can see the holes I drilled there, and so this thing fits in there pretty good now. I was thinking about gluing it in place, but I think I'll just, when I solder to this, the wires that I solder to this will hold it in place, and if I ever want to take it off, I can, if I unsolder it, it'll just come out again. So that's going to work for there. So now I have to just figure out kind of a layout to get all this to fit in here. And I still haven't, if you remember, I still haven't put together the floppy flipper side. I've got a plan for it, but I haven't tried it out yet. So these are going to be big. That 6800 microfarad capacitor, I've got one right there. It's part of the reason I chose that one, because I had one. That's not going to fit on this board, so I don't know where I'm going to stick this, but I may just strap it up underneath the game. But maybe I'll put those two on here. And then just have a wire going to this off to the side. That's kind of what I'm thinking anyway. All right, so I got this board all soldered up. I only went up to the left of my hand there. I didn't, well, including the flipper relay. So it doesn't include that stuff behind my hand, which is all the weak flipper stuff. It's everything else. And I checked it and rechecked it. I think it's all right. It's kind of ugly on the other side. I should have laid all this stuff out first, because some of the time I ended up crossing wires, and you know, I don't really know what I'm doing here. So I'm just playing around. But anyway, so I got the 4 inputs. I got the 50 volts in. I've got a ground. I've got the 5 volts in, and that would be my tilt bob. When that goes to ground, that resets it. I said I was going to socket 2 things, that resistor and that cap. I ended up soldering the cap. I figured I got enough play with just that one resistor. So if I want to make it longer or slower acting, I can just pop that one little resistor out there. Right now I've got the 220 kilo ohm. So if I want to make it in weak flippers longer, I can make that resistor bigger. Or if I want it to go faster, I can make that resistor smaller. So I'm going to throw this back in that black pyramid and see if it's working again like it was, because I took it from here, then I plugged it in here. I went ahead, I had these big 1 watt resistors in here. I got some 1/4 watt resistors because I didn't need those big ones, and ended up just grabbing another tip 102 for whatever reason. Anyway, let's go see if we do a smoke test. All right, so I got this thing wired up. I've got my red one going up to the 5 volts. I've got this other big red one, that's my 50 volts. I'm gonna put it up here, and I don't have a lug, but I've got the 43 volt test pad up, so I'm gonna have to manually hold that. I've got my ground going over to ground, and this is my tilt bob, so when I ground that one, I think I can just reach over there and touch that to the ground strap, and it should reset. So that's the scary part. So I'm gonna turn it on. Hopefully it doesn't smoke my board and or the machine. Okay, nothing yet. So I believe as soon as I touch this 43 volts up here, it should click. I'm gonna touch it right now. Yes, and it is clicking. You can see it moving. So I'm gonna hold that. I'm gonna have to get the stand because I need another hand because I can't touch that orange one to the ground. Let me go get the stand for the camera.
Go.
Okay, so I got Jane to hold the camera for me, so it's going on and off and on and off. So I'm gonna engage it. Now I'm going to touch the tilt. It went off. 1, 2. Okay, 1, 2. Perfect. It went about 10 or 11 seconds. So I'll do it one more time. That was about 9 seconds. So cool. I think that part of it's working. So now I just need to wire up the weak ass flippers. Jane's laughing. She's not really knowing what I'm saying. No.
Really?
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 Yes.
Dude.
Yeah. So now I need to wire up the rest of this. So the first thing I would do is figure out which of these contacts are which. So I believe it's, yeah, so these two are and those two are when it's engaged. So in the normal state of gameplay, it's actually would be these two would be engaged. So basically we want to pass the current through here. Either actually we'll only use one side of this. We don't need the other side. So this is the common, well, that's the common one there, I believe. Yeah, so that one there is that lead there, and it's either on that one or that one. That's the make or break. So this is essentially that post there is that one there, and those two are those two as drawn. So my 50 volts, I need to bring in 50 volts into that pin there, and it would come out on that. It will come out on that pin there to go to the normal flippers, and it'll come out on that one for the WAF. That way. So that's the way I need to wire it up. So yeah, I've got another little loop to do where I got to cross the voltage over. So another poor planning on my part. So I kind of redid this section so I wouldn't have to cross the lines. I've got the 50 volts coming in directly to that common lead, and then I just took a smaller jumper over to the coil that drives this flipper relay, because this one doesn't need the power, but the flippers do need the power. So I've got an 18 gauge wire going directly to there, and then it tapped off from that. So it's a little cleaner, and I also don't have to cross the wires so much. So I'm still going to have to get the ground off the board. I'm going to deal with that after, but before I do that, I've got to get this 100 ohm resistor, and we need about 25 watts. So what I do have here, I don't have that exactly, but I have 5 20 ohm resistors and 5 watts apiece. So I put that in series. I have a 100 ohm resistor at 25 watts. So, because each of these are dropping, it works out the math. So they're not going to fit on this board. I don't know exactly how I'm going to wire them up. I mean, in series, but I think I could probably, I don't know, stair step them or put them together in some kind of combination and wrap them together so they're nice and compact. Something like that, maybe. Maybe zip tie that and then wrap the wires so they're all in series. I don't know if I'm even on the screen there. I think I'll try to do something like that, and I don't know. I might just set them next to it, or I don't know where I'll put them. Maybe I'll just set it up against here next to the cap. I can zip tie the whole bundle to the cap because it's wired right there next to that cap. So anyway, that's kind of my plan. I'll just see what I get when I get it here. So I was just thinking to myself, some of y'all were probably thinking this too, probably the worst thing you could do is stack all these together and then expect them to get 25 watts out of them, because you got all the sides that are touching. So with the sides that are touching, they're not releasing any heat at all. So that's going to reduce all those surfaces where they're touching one another. Like this one here, it goes from a 5 watt to effectively 2.5 watt because it's sharing half the surface area is common. So almost, if you ignore the ends. So yeah, so I'm going from a 25 watt down to like a 15 watt effectively, or something like that, by stacking them together. But I'm probably going to do it anyway. I don't know. All right, so I got the rest of this all wired up. I took those 5 resistors and I just put them in series, kind of daisy chained them. So I started from, this is the weak side of it, went through there, goes through the 5 resistors. That's 100 ohms, that's that one there. And it attaches to the positive side of the cap, that's there. And from there, I didn't put in that 1 ohm resistor. I might do that later if I need to. And then it goes to the weak flipper state. So that's the weak one there. This one here, this is the ground for the whole board right here. It's all tied together back up underneath here. And for the normal flippers, so this is the 50 volts coming in here, and in the normal state, it comes right back out right there. So, geez, is that a hack job? You bet it is. Is it going to work? Well, I may do this on another video. This one's getting long. That's kind of a tease, isn't it? Of course, y'all may never see this one. If it blows up and has a forest fire, I may never even post this thing. I don't know. I might be too embarrassed. I'm kind of embarrassed the way this thing looks, to be honest. But, I'm a little too old to be embarrassed, frankly. So, I'll probably post it.